So this is for build an atom inquiry. And it's important that you come to this assignment from the lesson plan or from the home page. And when you do that, it will launch this screen, which is the landing page for the assignment. When we did this, we had 2 days to work on it. So the first thing that you're going to want to do is open the simulation in a new window by right clicking. So if you right click here and choose that, it will open it in a new tab for you. And it will open this simulation. Looks like that. The second thing that I need you to do is make a copy of this Google Doc template. So when you click on it, it's going to bring up this screen that says Google Doc template. And then you're just going to click here, use template, and it will make you your very own copy of the Google Doc. So this is most of the time our labs are done in Google Docs. So then right away now I want you to type your name, and I'm just going to put class copy for mine. So the research question we're investigating is, how do subatomic particles, protons, neutrons, and electrons affect the charge and stability of the first 10 elements? So part 1 is data collection, and then part 2 is analysis, where you will use your observations and data to answer to describe some terms that you learned about by doing the simulation. So for the data collection, you will design 10 controlled experiments, and each row represents one atom model. So like this is atom model 1, 2, 3, 4, etc. You will need to design a fair test for each model. So you'll remember back from physics last year that a fair test means we just are changing one variable at a time so that we can be sure that the observations that we make can be attributed to the change that we made. So there will be some controlled variables and some not. You want to learn how each particle type, proton, electron, and neutrons, affects the variables listed in the observation columns. Number 3, your observations must be as detailed and specific as possible, and you're trying to connect the variable that you changed to the outcome that you observed for the symbol, the mass number, and the charge. And then we've already opened the PhET build an atom, but that link will also take you. So we're going to do row 1, and we'll do models 1 and models 2 together to make sure that you know what to do, because you are trying to do this on your own. So we're going to go back over to the atom model, and we're going to click the one that opens the atom. Let me just move my face out of the way. Where can I be? I'll put it down here. So then you also want to make sure that you click this arrow to open up the net charge meter, and you want to open up the mass number meter. And down here, you want to click stable versus unstable. You can do cloud or orbits, but I want you to use orbits. So please make sure that you have orbits, and you'll see the blue rings. The model has protons that are red spheres, neutrons that are gray spheres, and electrons, which are blue spheres. So if we look at our data table, we're all starting with a model that has one proton, one electron, and one neutron. So we're going to go back to this, and we're going to drag one proton. And as we drag that in, we can see some things happening, all right? So we see it says hydrogen, and over here we see the symbol H. And then at net charge, we can see there's a +1. And by mass number, I see a number 1. All right, so if I drag it back out, all those are 0. And if I drag it back in, then we can see that it's hydrogen, it's +1, and it's 1. So we're going to record those observations before we do anything else, all right? So we added one proton, and saw the symbol become hydrogen, all right, hydrogen. All right, we need to drag a neutron into the middle. If we drag a neutron into the middle, the symbol doesn't change, but the mass number goes up by 1. Right, and we need to add an electron. So we add an electron, right? So notice that the electron goes to the inner ring, all right? I can't put it in the outer ring. So we add an electron, and now we have a proton and neutron in the middle. We can't put those in the rings. And we have an electron in the inner ring. We can't put it in the outer ring. And by adding the electron, the net charge went to 0, but the mass number didn't change and the identity didn't change. So adding an electron made the net charge go to 0. All right, so the mass number is 2, the net charge is 0, and the stability is the last thing. So it says stable underneath here, and that's all we really know. And then when we have 0 charge, it says a neutral atom. So we're going to add to our description that it's a neutral atom and it's a stable nucleus. So we put stable here, and then we put okay, we maybe don't know what neutral means yet. Now, what I mean from here on out, every model that you create needs to have at least one other model as a control. So I had some students put 2, 2, 2, and we cannot do that because that would be adding all 3 particles at the same time. So we can't clearly say without careful observation, which particle change is changing which dependent variable. So you only want to change one particle number at a time. Now that said, your models don't have to be adjacent to each other in the data table. So let's ask the question, what happens if I add one more proton? So if I add one more proton and I keep everything else constant compared to model 1, then that stays 1 and that stays 1. All right, so what happens if I change protons? All right, so we're going to go to our model and we're going to just add one proton to the middle. And now we'll collect our data. So we added one proton to the middle and everything else stayed the same. So our symbol now became He. And our mass number went up to 3. Right, so it was 2 and now it's 3. And our net charge went to +1 and it stayed stable. All right, so adding that one proton changed the symbol from, oops, I can't type. Increased the mass number by 1. Changed the charge from 0 to +1. Now, you are going to continue to build 8 more models, making sure that you always have at least one other model as a control. So you don't have to keep, I advise you not to do, you want to try to investigate the impact of each of these different kinds of particles. So one idea you might have is, well, I'm just going to do 3, 4, 5, 6, 7, 8, 9, 10 protons. Well, if you do that, you are only going to ever be able to conclude about protons. So I also want you to be able to find out about electrons, and I want you to be able to find out about neutrons. So what is the impact of each of these types of subatomic particles on the different parts of the atom model? So you should always build one like that, okay? And I'm grading you on your ability to design these tests. So that's why I'm not going to keep on going through that. Now, when you get down to part 2, what you're going to do is you're going to type, please type with your cursor below the word because I want it in blue text. I know that seems silly, but it makes it so much easier for me to grade your work. And what you're going to do is describe what you learned about this atom part. So about the atomic structure. What did you learn about the atomic structure by doing this? And you want to specifically tell me which models did you learn your conclusions from? Or how did the simulation teach you that? It is very important that you do not Google these and type a definition. I don't want you to bring any outside information in at all. If you have collected FAIR tests in order to investigate the effect of changing each particle individually, you will easily be able to define these terms. So here's an example answer. I learned electrons go in the rings because the sim would not let me put them in the middle. And then the charge on the electrons must be fill in the blank because in the model to fill in the blank. All right, so that's the structure that I'm looking for in your analysis. And then the rubric in the assignment explains how this will be graded. So I hope this helps. Please email me as you do it if you need help.